For lesson 8.2, you'll be solving two-step equations. And you'll be able to solve two-step equations and solve real-world problems involving two-step equations. There are no vocabulary words. Actually, there's one vocabulary word that you're not writing the definition down for. Two-step equation is simply an equation that contains two operations. Typically, in a two-step equation, the first thing you're going to do is you're going to add or subtract, and the second step is going to be to multiply or divide. Okay, we're going to talk about all sorts of equations this chapter, but a typical two-step equation involves those two steps, adding or subtracting first, and then multiplying or dividing. There are a couple of methods for you to consider. A vertical method, which is the way I was taught and which is the way I will continue to show you, but it's also valid to know that there is another method of showing your work horizontally. So please take a look at both of those methods and decide which one you would like to do, which makes most sense for you. So at the bottom of page 333, we're solving two-step equations first by adding or subtracting. In this case, we're trying to isolate the variable x. We're going to take care of the 6 second. The first thing we're going to do is get rid of this 1 by subtracting 1. And everything you do in equations should be shown twice. If you're going to subtract 1, you should show it subtracting 1 from both sides of the equal sign. When you subtract 1, this is gone, and what we're left with is 6x equals 25 minus 1, which is 24. And then we're going to divide both sides by 6. Even though that's something that you can do mentally, I'd like for you to get in the habit of showing that work of dividing by that coefficient. And finally, we have an answer of x equals 4. For 1b, same thing. We're going to get rid of that constant there, that 5, actually negative 5, by adding 5. As long as we add 5 to the negative 33, leaving us with 4x equals negative 28. And then we're going to isolate that variable x by dividing by the coefficient 4. 4 divided by 4 is 1, leaving x by itself. And then we divide by 4 on the right-hand side. Negative 28 divided by 4 is negative 7. Please don't just write those answers down on your sheet. Please show those steps because it's going to help us later when we get into multi-step problems. On page 334, we have a few more examples here. At the top, that coefficient of the x is back to being a fraction. So we still need to take care of our addition or subtraction first. In the case of 2a, we're going to get rid of this 15 first. Again, we're paying attention to the side where the variable is. We want to isolate the variable, so we have to get rid of the 1/3 and the 15. We're going to get rid of the 15 by subtracting 15. When we take 15, take away 15, that's 0. And we're left with 1/3 n on the right, and 8 minus 15 is negative 7. We're going to get rid of the 1/3 by doing the opposite operation of multiplying by 1/3. We're going to divide by 1/3, which again, this is confusing. It's going to confuse you if you don't really think about it. 1/3 n, we could show our work like this, dividing by 1/3, but really when we divide fractions, we multiply by the reciprocal. When we do that, we get the 3's to cancel out and the 1's to cancel out, and then our n, our variable, is isolated. As long as we multiply both sides by the same. In this case, we're left with 3 times negative 7, which is negative 21, is equal to n. And we can put that back into our original equation. What's 1/3 of negative 21? It is negative 7. Negative 7 plus 15 is equal to 8. You can always substitute it back in to make sure it works. On 2b, we're going to add 3 to both sides. You might say, how did you know to add 3? Why didn't we do something with the 2? Again, I'm looking for the side that has the variable. I want to get everything away from that variable. I'm always going to take care of the coefficient of the variable last. So in this case, I added 3 to both sides to get negative 16x equals, that cancels out. I'm not going to put a 0 down here. I'm just going to leave that. 2 plus 3 is 5. Now multiply by 6 over 1, but don't forget that negative there. We've got to multiply by a negative 6 over 1, so we can cancel it out. Multiply by negative 6 over 1, and we get x equals negative 30. Okay? Going down to example 3, we have what seems like just a one-step problem, but it's kind of sneaky, and that's a two-step problem, and I'll show you why. First of all, we want to isolate the b, but actually that b is a negative b. It's a minus b, so let's pay attention to that as we're doing these next example problems. To get rid of the 15, we're going to add 15 to both sides. That's pretty easy. We have negative b equals 59, but we don't want to know what a negative b is. We want to know what a positive b is. And how we can get rid of that negative sign is to divide by a negative. A negative divided by a negative is a positive. As long as I do the same thing to both sides, we get b equals 59 divided by negative 1, which is negative 59. Let's try this one, 3b. Add 4.3, add 4.3. So we have negative 6.5 plus 4.3. We have different signs, so I'm actually going to subtract here. Actually, I don't need to borrow. 5 minus 3 is 2. 6 minus 4 is 2. And there's more negatives, so it's going to be negative 2.2 equals negative n. But we don't want to know what a negative n is. We want to know what a positive n is. So we're going to divide by a negative 1 on both sides, leaving n equals a negative 2.2 divided by a negative 1 is a positive 2.2. Okay? Again, negatives are always going to be where you make your mistakes, not paying attention to details. So as long as you're showing your work and paying attention to those details, you should be fine. Example 4 has us doing actually what I call a three-step equation, because the first thing we're going to do on these is we're going to combine like terms. Okay, and I didn't circle that negative sign there. We have some like terms here. So what we have is 4, and then negative 9c plus 3c is negative 6c, and then we have 58. That's the first step. Okay. Now what we have is, I'm going to write it over here. 4 minus 6c equals 58. Get rid of the 4 by subtracting 4, and we have a negative 6c equals 54. Divide by negative 6, divide by negative 6, c equals negative 9. Okay. Again, example 4 is actually what I think is a three-step equation, because first we're going to combine any like terms. Okay, so we have in this case 0.4m plus 0.2m. So I'm going to rewrite that as 3.4 equals 0.6m minus 2. Okay, then I'm going to add 2 to both sides, add 2. We get 5.4 equals 0.6m, divide by 0.6, divide by 0.6, and we get m equals 9. Okay. These should all kind of look like a funnel coming down and getting smaller and smaller. I didn't have enough room down here to put, well, m equals 9. So that's how they should look. Okay, not kind of scattered all over the place. All right, going on to page 335. I don't think we have an example 5. Actually, we do. Example 5 on page 335. We have a story problem that we're going to turn into a two-step equation. Actually, it already has the two-step equation written for you right here. Whoops. Right there. So I'm going to write that over here on the left. 105.4 plus 20.6x equals 682.20. We're going to subtract $105.40, and then we're going to divide by 20.6. As soon as I subtract here, 7, 12, 11, and then 12, we should get 8, 6, 7, 5. And then when you divide both sides by 20.6, divide by 20.6, x equals, let me pull up my calculator right here and type in 576.8 divided by 20.6, and it comes out to be 28. And if just in case you're wondering about calculators, if you're going to show your work like this, I would absolutely let you check your work with a calculator. But if you're not going to show your work and you're just writing in the answer, I will not let you use a calculator. So keep that in mind. Okay. Lesson 8.2 was all about two-step equations and actually a few three-step equations. Make sure to show your work, check your homework, and then let me know if you need any help.